Right, in this video we're going to be having a look at an examination question. What we have already is a ball of mass 0.25 kilograms is swung on the end of a string with a radius of 1.5 meters. It travels at 8.6 meters per second. So at the moment we've got the following. We've got the mass, which is 0.25 kilograms. We've got V as in 8.6 meters per second, and we've also got the radius, which is 1.5 meters. So this here is given to us in the question, and the first thing it says is calculate the angle turned after 0.4 seconds. So the way we do this is we to calculate the angle rotated about after a certain time. The equation is actually 2 pi t over t, and what we do is we need to actually work out. We've got small t, which is 0.4 seconds. That's the time after the time we're after, and big T is the only thing we haven't got. So to work out big T, we're going to use V is equal to 2 pi r over t. I'm going to rearrange this for t. So t is equal to 2 pi r over v. So therefore we've got 2 times by pi times by 1.5 all over v, and in v in our case is 8.6. So that gives you an answer of 1.096 seconds. And then what you do is you basically put that into there. So the using this equation over here, we do 2 times by pi times by small t, which is 0.4, all over 1.096. So 2 times by pi times by 0.4 divided by 1.096, and we get an answer of 2.3 radians. And 2.3 radians is, if you put that into degrees, that is actually about 131 degrees. So that's about 131 degrees. And all I did there was I times that by 180 and divide it by pi, and you get 131 degrees. So the next question is calculate the tension in the wire itself. So the tension in our case, we've got something going around in a circle, and it's attached to a string like this, and the only thing providing any tension here is actually the centripetal force itself. So Fc is given by mv squared over r. So in our case we do 0.25 times by v, which is 8.6 squared, and then divided by 1.5, which is the radius. And an answer, you should get an answer here of 12.3 newtons. The last question, it says calculate the frequency when the tension is 60 newtons. So what we're going to do is we're going to actually calculate the frequency here, but there's actually 2 different equations we're going to use. The first one is we're going to use F is equal to m omega squared r, and then we're also going to use omega is equal to 2 pi f. And we're going to rearrange this one for omega over 2 pi to give us f, and then this one we're going to rearrange this one for omega. So the equation here becomes square root of f over mr is equal to omega. So all we need to do now is just put our numbers in. So for the first equation, we've got a tension, we've got a force. The tension is 60 newtons divided by the mass, which is 0.25. and we times it by the radius, and we get an answer there of 12.65 radians per second. And then what we do is we bring that over here, so we do 12.65 divided by 2 times by pi, and we get an answer of around 2 hertz. So that's how you do an examination question like that.